Hi. Today we're going to go over the PAT paper from 2009 looking at question 26. Okay, so question 26 told an electron gun in a cathode ray tube accelerates an electron of mass m and charge E to across a voltage of 50 volts and directs it towards a screen. So it's fired horizontally towards a screen 0.4 meters away, and we're asked how far does it fall during its journey. Okay, so this question is actually just a simple mechanics question, just disguised in the form of something more complicated, because they've used electrons rather than your usual just mass moving. So what I would suggest to start with is by calculating what you can from the information given to you. So we want to find how far it falls during its journey. So what you need to do is you'll probably need to work out how fast it's going when it leaves the cathode ray tube. And well, a way to do that would be to calculate its kinetic energy after it's been accelerated through the tube. But where does this kinetic energy come from? Well, we know it's accelerated across a potential difference, and we have its charge. And we know that energy is voltage times charge. So we can say that the kinetic energy it gains, so the change in EK, is equal to the energy it gains from the voltage. So that's E, the electronic charge, times the voltage V, i.e. 50 times its charge, 1.6 times 10 to the minus 19. Okay, so 1/2 mv squared, its kinetic energy, is equal to 50 times 1.6 times 10 to the minus 19. So timesing by 2 and dividing by its mass, we get v squared equals to 100 times 1.6 times 10 to the minus 19, which is 1.6 times 10 to the minus 17, divided by the mass m, which we're told is 10 to the minus 30. Well, that's equal to 1.6 times 10 to the 13, which is equal to 16 times 10 to the 12. And therefore we see it leaves the tube with a velocity v equal to 4 times 10 to the 6 meters per second. Okay, so now let's think about what we have here. So you have an electron leaving the tube at some speed v, going towards a screen. And we know it's going to follow a parabolic path because it's a projectile moving under gravity. It's going to move like this. So we know again that its vertical and horizontal velocity is going to be independent of one another. So as it's fired horizontally, it leaves with a 0 vertical speed. And well, there's no forces acting in the horizontal plane. The only force acting on it when it leaves the tube is going to be gravity. We're not told about any electric field or any other force. So we can assume that we know that it will travel at exactly the same speed horizontally for its entire duration. So we can actually work out its time from that. So the time of travel will be the distance it travels over its speed. So that's distance over speed. And well, the distance we know is 0.4 meters, and its speed is 4 times 10 to the 6. So that gives us a time of travel of 1 times 10 to the minus 7 seconds. Okay, well, now we can work out how far it drops. So let's quickly sketch it on again. So it's leaving like this with speed v, going towards the screen like this. So let's consider its vertical motion. So let's define downwards as positive. So what's its displacement? We don't know that. We want to find that out. Its initial velocity is 0. V, well, we're not concerned with that. We don't want to find that. We don't know it. A is gravity, 10, being positive because downwards positive. And T, well, we just work that out as 1 times 10 to the minus 7. Okay. Then we can simply plug it in. So we know that S is ut plus 1/2 at squared. U is 0 and A is 10. So that gives us 5t squared, which is 5 times 1 times 10 to the minus 7 squared, which gives us 5 times 10 to the minus 14 meters. And that's the answer.